Hello everyone, welcome to my channel. First, let me introduce myself. My name is Fahreza. I am from the test science class and my lecturer is Mr. Wahyono. Today, I would like to present about the prediction the number of COVID-19 cases in Indonesia. The number of positive cases of coronavirus in Indonesia has continued to surge in the past months. Since the announcement of the first positive COVID-19 case in the country on June March 2020, additional numbers of people were found to be infected with coronavirus. This information focuses on the case in Indonesia. Visualization in this project using Matplotlib for generating graphs such as line plot, bar chart, area plot, and pie chart. I also predict the number of cases for the next 10 days using regression algorithms such as Polynomial Regression, Vector Regression, and Bayesian Ridge Regression. I use time series data from the data repository created by John Hopkins CSSE. The data is updated daily. Thank you for John Hopkins. I hope with my presentation we will know how to implement the prediction, the time series prediction using data science approach. First, we must to import library like that. Import NumPy, Matplotlib, Pandas, time, scalar, and so on. After that, we have to load the data. In this case, we have 3 file GSP. And then we load into 3 data frame. After that, we have to explore and extract the data. Because the data is very large, there are data from the whole world. So we must to filter just for Indonesia cases. I observed the numbers start from the June March 2020 when the first case to be found in Indonesia until 1 May 2020. And then we will store it into 3 variables. We don't need pre-processing because the data is tidy. Then we will transpose the shape of this variable so that's switchable with the number of input data in model prediction. After that, we combine 3 columns into 1 frame. 3 columns Indonesia confirm, Indonesia dead, Indonesia recovery into 1 frame. And then this is the tail of the data. Confirm, dead, and recovery in 1 frame. And I will try to visualization with line chart. As we can see, this is the line chart of the confirmed case in the blue area and the dead case in the red area and the recovery case in the yellow area. And I will try to visualization with bar chart. We can see the difference with confirmed case, dead case, and recovery case. Confirmed case has 10,551 cases. And how about the date? The date is just only 800 cases. And the further recovery is 1,591. So this is the percentage. The percentage of the active case is 77.3% of the total case in Indonesia. So I think this too many. But we can see the dead case is just 7.6%. So this is a little. if we compare about the active case, I hope the recovery case will grow until 100. So the Indonesian people is free from corona. This is the data visualization with daily case increase. For the daily case increase, first we have to define the function to get the daily increase like that. And then we can calculate the confirmed daily increase, the daily increase, and recovery daily increase like picture we see. So the blue line is the confirmed case. We can see the data day to day is so volatile and nonlinear. And about the dead case and recovery case, the line is looks similar, but until now we can see the recovery case is higher than the dead case. Now, so before we create a prediction model, we have to split the data training and testing. For splitting the data, I use 80 and 20 proportion with 80% used for training data and 20% used for testing data. I also set the shuffle parameter into false in order not to randomize the splitting. So the first 80% of the data will be used as the training data, and the last 20% will be used as the testing data. Now, okay, I will make a model prediction using polynomial regression first. Actually, I have make a 3 model prediction in this presentation. Now, we can talk about the polynomial regression first. Polynomial regression is a form of linear regression in which the relationship between the independent variable x and dependent variable y is modeled as 4-degree polynomial in this case. The basic goal of regression analysis is to model the expected value of the dependent variable y in terms of the value of an independent variable x. In simple regression, we use following equation: y for the dependent variable and b is population, y-intercept, and b1 is population slope coefficient, and x for the independent variable, and e for random error term. So this is the script. I will use the 4-degree in the polynomial feature, and then we will fit the data into the model classifier. And this is the result. The blue line is confirmed case, and dot line is polynomial regression prediction. We can see the data, there are a little error in this, but not too much. So next, we can see how about the support vector regression. SVR give us the flexibility to define how much error is acceptable in our model, and will find an appropriate line to fit the data. So this is the main idea of the SVR. SVR can define how much error is acceptable in our model. Error in this formula is denoted as epsilon. So we will define the threshold of the error, the acceptable error, like this formula. The error term is instead handled in the constraint, where we set the absolute error less than or equal to a species margin called the maximum error epsilon. So this is the script to fit the data into the SVR model. We use kernel polynomial and gamma 0.01 and epsilon is 1. We define error just 1. So we can plot the data and we get a result. The dot red line is the SVM prediction and the blue line is the confirmed case. You can see there are a little error in this case. And the last, we will try to create a model prediction using Bayesian Ridge Regression. In the Bayesian viewpoint, we formulate linear regression using probability distribution rather than point estimates. The response y is not estimated as a single value, but is assumed to be drawn from a probability distribution. The model for Bayesian linear regression with the response sample from normal distribution is like that. There is y, and beta transpose x for the data, and theta square I. The output y is generated from a normal Gaussian distribution characterized by a mean and variance. The mean for linear regression is the transpose of the weight matrix multiplied by predictor matrix. The variance is the square of the standard deviation multiplied by the identity matrix because this is a multidimensional formulation of the model. The aim of Bayesian linear regression is not to find the single best value of the model parameters, but rather to determine the posterior distribution for the model parameters. Not only is the response generated from a probability distribution, but the model parameters are assumed to come from a distribution as well. The posterior probability of the model parameters is conditional upon the training input and output. So this is the different Bayesian with the linear regression. In the Bayesian, we use probability distribution rather than point estimates. So this is probability equation in Bayesian. I will try to implement this model in the Python. So I will import the Bayesian in Skitler, and then we will fit the data into the model. This is the data poly x train confirm and y train confirm. After that, we can predict the data using Bayesian model and then store the result in the test Bayesian pred variable. And we can plot the result, and as we can see, this is the result. I think the result is not too much error if we compare about the others model like SVR and polynomial. So this is the result. This is the result for the polynomial regression. As you can see, we have 10 data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 from the 2 May 2020 until 11 May 2020. And we can see this is the main average errors and this is the main square error. For